So the reason that my calculation didn't quite work in this last slide was that I had incorrectly transcribed this Mobius transformations matrix into a Mobius transformation. The numerator is indeed x plus 1, but the denominator is minus x, not minus 1, as I had previously done. Right? So we'll use that now, and this should give us a more sensible answer. So what I want, right, is I want to find what is my t function, my function which is going to represent the infinite order twist in my group of functions which behaves like the group of rational tangles does. Right? And since r is a function which is its own inverse, the opposite reciprocal function, r inverse of this is just going to be the opposite reciprocal of this. So t of x is going to be minus 1 over x plus 1 over minus x. And so I do that arithmetic out. I'm going to get x over x plus 1. So there is now an example of a function which is going to have infinite order. X over x plus 1 has infinite order. And when I compose it with r in this way, the composition of those two things is going to give me an order 3 function, a cube root, a functional cube root of the identity. But again, having done this work, we still don't necessarily have the simplest version of this t function that we could possibly use. That simplest version, at least the choice that's canonically made when we do this work, belongs to the simple add 1 function. Right? But I think we can convince ourselves that, for example, if my function takes and divides a number by 1 more than itself, right? Let's say I start with 1. After one iteration of applying this function, I'm going to get 1/2. Then after that, it's 1/2 divided by 1/2 plus 1, and it's going to give me 1/2 over 3/2. That's going to be 1/3. And then after that, I'm going to get 1/4, 1/5, 1/6. So however many times I do that, I'm never going to get back to my original number, right? It's always going to be, this iterated function is always going to be decreasing, decreasing, decreasing. And the simpler version, the one that we're going to go with, is one that instead of decreasing constantly, just increases constantly. Every time I twist, I add 1 to my number. And that's never going to wrap me back around to where I started, because I'm always increasing in this formulation.